Guys, Sergian again here. So welcome to another lecture series. In this lecture, we're going to discuss powers of sine and cosine. So for integration of powers of sine and cosine, so we need to first familiarize ourselves with the three cases in this manner. So the first case that we have here, sample problem number 1, so cosine raised to 5x and then sine raised to 4x dx. So this is a sample of case number 1. So for case number 1, so cosine is odd and sine is even, or one odd and then one even. So for this case, we're going to isolate one cosine or one sine depending on the equation, such that if you isolate one and get the derivative of the other function, then that can be substituted. Alright, so if we isolate one cosine here, so we can write the equation as the integral of cosine raised to 4x sine raised to 4x cosine x dx. Then, we're going to change the other function. So for this case, we're going to change the remaining cosine into sine using identity. Recall that cosine squared x or theta is equal to 1 minus sine squared x. So we're going to use that identity. But before that, we need to write this as integral of cosine squared x raised to squared sine raised to 4x cosine x dx. So we can now apply the identity. So we have integral of 1 minus sine squared x raised to squared sine raised to 4x cosine x dx. Then let's expand this. So we have 1, this times 2. So we have negative 2 sine squared x. Then square of the last term, so we have positive sine raised to 4x multiplied by sine raised to 4x cosine x dx. Now, we further distribute this, so we have integral of sine raised to 4x minus 2 sine raised to 6x plus sine raised to 8x quantity cosine x dx. Now, we can apply u substitution such that if we let u be equal to sine x, the derivative of u or du then be equal to cosine of x dx, and this is cosine x dx. Therefore, we have here integral of u raised to 4 minus 2u raised to 6 plus u raised to 8 quantity du. Alright, so this is integral of a certain function. So integral of u raised to 4 du minus integral of 2u raised to 6 du plus integral of u raised to 8 du. So everything is integrable. So therefore we have here u raised to 4 du. So this is power rule. So we have here u raised to 5 all over 5 minus factor out 2 outside. So we have u raised to 7 all over 7 plus u raised to 9 all over 9 plus c. Back substitute. So we have sine raised to 5x all over 5 minus 2 sine raised to 7x all over 7 plus sine raised to 9x all over 9 plus c. And that is now the integral of this function. Alright, so did you get it right? Alright. So we're going to discuss the next case after it. Alright. So we have here now case number 2. So as you can see, we have here two functions again of cosine and sine. But as you can see, the exponents are both odd. So if you have both odd exponents, so therefore, you isolate one sine and then you isolate another cosine. Okay. So for that case, and then change everything to one identity. So case 2, we have both are odd. Okay. So we isolate one sine and then we isolate one cosine. So that we'll have or we can isolate one sine or one cosine depending on the equation. So that, for this case, we just isolate one cosine here and then take the derivative and then we have the substitution. Alright. So we can rewrite this as cosine squared x, sine of cube x, cosine x, dx. Alright. So for that case, we can change cosine x to sine. So we have 1 minus sine squared x, sine of cube x, cosine of x, dx. Alright. Then we distribute. So we have here integral of sine of cube x minus sine raised to 5x quantity cosine x dx. So if we let u be equal to sine x, then du would then be equal to cosine x dx, such that we can apply the substitution. So we can write this as integral of u cubed minus u raised to 5, and then this would be du. Alright. So this is now integrable. So therefore, we have your integral of u cubed du minus integral of u raised to 5 du. So we have u raised to 4 all over 4 minus u raised to 6 all over 6 plus c. Back substitute u. So therefore we have sine raised to 4x all over 4 minus sine raised to 6x all over 6 plus c. And this is now the integral of that. Alright, now let's go to the last case. So for the last case, so we have here both of them are even. So if both of them are even, so we'll just transform them as one odd exponent of 1. So therefore, we have an identity. Sine squared x can be rewritten as 1 minus cosine of 2x all over 2. And cosine squared of x can be written as 1 plus cosine 2x all over 2 from double angle identities. Alright. So therefore, we can rewrite this as the integral of 1 minus cosine of 2x all over 2 times 1 plus cosine of 2x all over 2 quantity dx. 2 times 2 is equal to 4. So therefore, we'll factor out 1/4. So therefore, we have here 1 minus cosine of 2x and then 1 plus cosine of 2x dx. So this is difference of two squares, and this is factor part of difference of two squares. So therefore, we have 1 all over 4, the integral of 1 minus cosine squared 2x dx. This has an identity. Recall, sine squared x plus cosine squared x is equals to 1. And if we're going to transpose cosine to the other side, so therefore we have sine squared x is equals to 1 minus cosine squared of x. So this is sine squared of 2x. So therefore we have 1 all over 4 integral of sine squared of 2x dx. This is not directly integrable, so we need to use identity. So we're going to use this again. So therefore we have 1 all over 4, the integral of 1 minus cosine of 2x all over 2 quantity dx. Let's factor out 2 up there, so that we'll have 1 all over 8, the integral of 1 minus cosine of 2x quantity dx. Oops, don't forget, we have here 2, so therefore we multiply this with 2. So therefore the angle becomes 4x instead of 2x. So we distribute, so we have 1 all over 8 integral of dx minus 1 all over 8 integral of cosine of 4x dx. So we let u be equal to 4x, du be equal to 4 dx. So we'll have a neutralizing factor or a balancing factor equal to 1 all over 4. So therefore, there would be 1/4 here. So therefore, the equation becomes 1 all over 8 integral of dx minus 1 all over 4 integral of cosine u du, and don't forget the 1 all over 8 which is given here. So integral of dx is simply x. So we have there x all over 8. And integral of cosine u is equal to sine u. So therefore, 4 times 8 is 32. So that would be sine u all over 32 plus c. Back substitute u. So we have x all over 8 minus sine of 4x all over 32 plus c. And that is now the answer for the integral of that function. So hope you learned something new in this video. So if you have some comments, you have suggestions, so hit me up in the comment button. So, and if you enjoyed this video and you learned something new, so don't forget to hit like and subscribe. So see you in the next lecture.